each question and just discuss what it entails. So that way you can kind of get an idea of what you need to be well versed on. Number one is solving the right triangle. Y'all, that's basic geometry. I'm gonna put geometry when it is literally a question I would give to my sophomores right now because we just finished the trig unit. It was solve a triangle. Number two ends up being law of sines. Number three is what we just came out of. It's the two forces of vectors acting at a certain point. They do not act at a right angle. It is not at a right angle. It just says at a point, which means you have to draw that parallelogram. And the resultant force is given. So, and then it says find the angle between the forces. So this one, if you look at my posted solutions, let me pull it up. No. Oh, you don't need one. You got a formula sheet. If you look at my posted solutions, I'm going to encroach for just a second. There we go. You've got the two forces, you draw, and you've got the resultant. You need to know that that comes out of the middle of the two forces that give you the length of it. Then it says find the angle between the forces. This is what they're asking for right here. You cannot find that right away. There's no way to find that right away. You have to find this first over here. And then you have to know that these add to 180. So I made a note for you to first find theta, which is over here in this corner. So you finish the parallelogram. That's 223, so is this. So your focus is on this triangle, 639, 223, that's a 3, 564, and this is the angle we need. So that's your focus, which means it's a law of cosines problem. So I used law of cosines to find the angle theta, and that gave me this angle in blue, theta, which means I could find the purple arc, the one they asked for, because the same side angles add to 180 in a parallelogram. If I had to say what's the hardest question on this exam, I would say that one, just because what they ask you to find is not readily available. You have to know to come over here and find this angle first. So this is probably the trickiest question. Okay? Now, had it said they act at a right angle, then the problem would have been solved using basic trig, which was on your exam yesterday, I think. Right? I think there was a question on the exam like that yesterday. But it says they just act at a point, which means it's not a rectangle, it's a parallelogram. So I'm going to go back to this paper, this page right here, and I'm going to write, tricky, and then I'm going to put law of cosines. Alright, so number 4 is basic trig. It's the 6 trig functions. I'm going to write geometry because it does not involve anything extra, but I know in geometry you didn't learn cosecant, secant, and cotangent. But it is the basic geometry, and it's writing the 6 trig ratios. It's writing them. Now, when I was writing your answer key, this box was way too small. So in the black ink is where the final answer is. In pencil is where I was first setting it up. but then you know you have to rationalize. And this is a very ugly number, very ugly. And so they're just trying to see, can you still rationalize with a very ugly radical? So like for instance, sine of theta. Actually that's the Greek letter phi, but I like theta better. Sine of theta, opposite over hypotenuse. So that's what I wrote, but that's not rationalized. So that's why this is the rationalized answer. Does that make sense? And if you remember, go all the way back to the beginning. If you write your sine, cosine, and tangent ratios, then go next to it and write your cosecant, secant, and cotan ratios right beside them. Why is that easier? What do? You just flip them. So like when sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. You just flip it, which is what I did right here. Which is why this is helpful, because right here where I have sine, and I go to flip it for cosecant, I can just flip it without rationalizing. Does that make sense? Like I don't want to flip this one, because then I'd have to rationalize that crap again. You want to flip the one that was not rationalized, because then it's easier. There's less work involved. So it helps to write out the first ratio, leave it there, then rationalize it. So when you get to the three reciprocal ones, it's easier. So you did have to do Pythagorean theorem first, then you just write your 6 trig ratios. Number 5 was basic geometry, and it was finding a missing side. I'm going to say find a side of a right triangle. I did write on there the word taught, not like she taught me, taught. T-A-U-T is a fancy word for when the rope is really tight. There's no slack in the rope. So where it says, assuming that the string is taut, I put on your solutions that just means it's tight. It's not, it's not, what's the word? There's no excess string hanging. Like the wind is really strong and the kite is about to fly away. Number 7, no, that was 5. Number 6 was law of cosines, and it was fill in the blank. On the first part was just fill in the blank. The second part was actually finish it, solve it. You did have to pay attention to the directions right here. It is saying find the largest angle of the triangle. Well, the largest angle of the triangle is going to be opposite of the largest side. So they're saying find the, in this case, side C. C is the largest side, which was your clue over here. If you notice, this was A, C, B. If you recall from Law of Cosines, the side you're finding corresponds with the angle at the end of it. So that's a way to make the connection, which answer choice there. I made a note. I'm trying to throw you off right here by saying, oh, are there 2 possible solutions? And I made a note that with an X here to show, no, that's not even an option, because that's only if it's the irate customer. And that is a side problem, which means there's either one solution or no solution. There's no chance of there being 2. So know when to mute that out when it's not relevant. Alright, 7, they give you a trig function and they tell you what quadrant it's in, and they say find the double angle, which is on your formula sheet. So I'm going to write double angle. And in this case, it was sine of 2 theta. Which means you've got to draw the picture. You've got to draw the picture in the correct quadrant. You've got to label your sides. Label your negatives correctly based on what quadrant you're in, okay? Watch your negatives. And then you go to your formula sheet. This is the formula for the double angle of sine. And then you just plug in the fractions. Find sine of theta, so that's opposite over hypotenuse. Find cosine of theta, and then you type it in the calculator. That's the only one from that entire middle section on your formula sheet with all of those trig identities. That's the only one that gets used. I didn't put a single prove or simplify on here. Number 8 is graphing a complex number and then finding its absolute value. Okay, a couple of people missed graphing yesterday. I don't remember who, but I think it was like 3 people. Let me write this. All right, so I'm going to write graph, and is it absolute value? Yeah. Absolute value complex number. Actually, I'm just going to write A plus BI, because that's shorter. All right, so that's what 8 covers. Let's go to it. Okay. It was negative 2i, which is the same thing as 0 minus 2i. This is your A, this is your B. A controls right or left. B controls up or down. So you would not move right or left, and then you would go down 2. And then the absolute value of the complex number is that formula. The absolute value of the complex number is the square root of a squared plus b squared. So a was 0, b is negative 2, put in parentheses, square root of 4 is 2. That's from the chapter we just finished. All right, 9. Given a function value of an acute angle, find the other 5 function values. Notice this in this case, they don't mention the quadrant. That's not relevant. It's just, hey, if sine is this, then what is cosine tangent, cosecant, secant, cotangent? So this is exactly like number 4. Entirely. It's exactly like number 4. When you look at them, you might think, oh, they look different. That's because number 4's question is testing whether you can run with an ugly radical. Number 9 is pretty numbers. Okay? So I'm going to write geom, and it's the 6 trig ratios. And it is exactly like number 4. I'm going to write next to it number 4, comma, number 9. Meaning it's repeating the same. It's just number 4 was ugly, number 9 is pretty. You do have to use the Pythagorean theorem to find the missing side first. Number 10. I made 10 way harder at first when I started to do this. I thought it wanted me to actually convert it and then write it in pi form, but then the directions say round to 2 decimal places, which means they want you to just know how to convert it and then just type it in the calculator. So number 10 is convert to radian, which means, or degree. It could change to degree, I don't know. So you need to know both. how about this? I'll write /degree. So the one you got questioned on was convert to radian, but it could give you radian and say convert to degree. But remember, that's where you're multiplying by either pi over, write it underneath, I like this. Whatever they give you, multiply by pi over 180 if you're going to radian, or if you multiply by 180 over pi if you're going to degree. Remember that? How do you know when to use which one? It's what you're going to. It has to correspond with the top of the fraction. And you just type it in the calculator. Let me pull mine up and show you. Right here. It just goes in the calculator. The whole thing. All of it. So if it had said convert pi over 6 to degrees, which it wouldn't because that's on the unit circle, that would just be 30. But you would multiply it by 180 over pi and type it in your calculator. Halfway through the test. Number 11. In the words of Maui. You're welcome. Number 11 is basic geometry, finding these 6 trig ratios, but this time they give you all 3 sides. You're welcome. So, right here, you've got number 4, 9, and 11. See where we're creating those are all the same type questions. 4 is the ugly radical, 9 is the pretty numbers, 11, they give you all the numbers. 4 and 9 have to do Pythagorean theorem. 12, knew it was coming. Law of sines, and in this case, I don't know if it would repeat on the exam tomorrow, but it is the irate customer. You got to watch out, check it. You can have no solution, you can have just the one, or you can have 2 solutions. In the review, this particular one had an error as I was trying to solve for the first angle, which means no solution. I would encourage you to go back to the mid-chapter 8 exam review and practice one of each. It's in your review. There's one in there that's an irate customer with 1 solution. There's an irate customer with, well, this one is no solution. And then practice the one with 2 solutions so you know how to check for it. Because I don't know what it's going to give you on the exam tomorrow. It just generates the questions based on the topic, not based on the answer. Does that make sense? So don't jump through the test tomorrow and just say, oh, this one was a no solution. It might have a solution. It's just generating a law of sines side angle problem. Okay? So 12 on this exam review is not enough to prep you for the exam questions tomorrow. So please pull those 2 from the mid-chapter 8 exam review. Number 13 is on your formula sheet. 13 is the range of the inverse trig functions, which is at the bottom of your formula sheet. If you get 13 wrong, it tells me you didn't listen. See your formula sheet? See the bold colors? Number 14. Write the complex number in trig form. That is from the test yesterday. No, you don't get a half sheet for the final because, yes.
The 13, is it open the circle or is it closed?
It's open. So on your that section, it was sine, cosine, tan, and sine, not sine, tan had opened because right there on the y-axis, when you do y over x, x is 0. So you can't have the 0 on the bottom, which is why it's an open circle. But great question. That's why it's A, not B. Uh, 14. Find the complex number in trig form. The formula for that is on your formula sheet. It tells you what to do. It says to find R, gives you the formula for finding R. Then you've got to know, you missed that part yesterday. To set up cosine is A over R, sine is B over R. You write the fractions, and then you go to your unit circle and just find what angle that is. I'll pull it up. Let me write complex number in trig form. Okay, so I'm going to put A plus BI in trig form. And then let me pull it up. So I found R. I let the calculator do that mess. I just typed the whole thing in my calculator. Then I set up cosine theta, A over R, sine theta, B over R, plugged it in, cleaned it up. That is the coordinate point I'm looking for on the unit circle, and it is at theta equals 30. So I filled it in. There's my R, there's my theta. Is a law of cosines problem. It's a side, 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 which means you do have to find two angles first using the law of cosines. Then the third angle is 180 minus those. Um, 16. Find the exact value of tan 30. I'm going to write unit circle as far as what's the topic, because I don't know that the test is going to give you a tan question tomorrow. It'd say find the exact value of sine 30, which would mean you just go to the unit circle and you pull the y value for 30 degrees. If it said find the exact value of cosine 30, you go to unit circle, you pull the x value. If it says tan, you've got to remember to pull the whole x and y, and then you have to divide them. It's y over x, and you've got to keep, change, flip, and rationalize, which is what you see here, right here. So I made a note that 30 degrees is this coordinate point. I copied it here. Then I said to myself, tan is y over x. So I plugged it in. I put, not KFC, but KCF to let you know, keep that, change this, flip it, which I did. 2's cancel, but it's got to be rationalized. Okay? So that's from the very first chapter. Find the area of the triangle. I'm going to write area of triangle, and then I'm putting in parentheses K because it's on your formula sheet. And you might be wondering, well, Ms. Holcombe, it's not on there. It's because it's not on that one. And yesterday, as I was doing the exam, one time through, yes, there it is. When I was doing the exam yesterday, I realized that the formula for the area of a triangle was not on there and needed to be. So I remade it. I squeezed it right in the middle, right here, and I'm going to recopy this for y'all. I'm not going. You don't need it right now, right? I mean, that's the only thing not on there. I put it, where is it? I put it right here in my solutions so that you would have it. Remember, all it is a matter of plugging in the sides and then the angle. This particular question, the angle that they give you is in degrees and minutes. I have no way of going in and telling it, just do degrees. But look at these answer choices. You're not close at all. So just ignore the minutes. Run with just the degrees, and you're going to get, when you type this in the calculator, you still get 36. The minutes are minute. They don't, minute, minute, spells. They don't change anything. So don't worry about the minutes there, just cut that off. I was hoping that would be an easy question for you, because you're just plugging it in. There's no tricks there. And you will have that answer, or that formula, on your formula sheet tomorrow. All right, 18. Find the rectangular coordinates. Find the rectangular coordinates. No, I'm going to run out of room. I'll do this. I'll figure it out. Hold on. So they give me the polar. Here we go. And we're going to rectangular. There it is. There's your topic. Which means they're giving you r and theta. You need to find x and y. Look at your formula sheet. Formula down towards the bottom. Oh, I need to add it. I'll add that too. Hold on. I had it memorized, so that's why it didn't stick out. You need that x is, where should I add this? No. I don't want it to be random. I'll put it right here. X equals r cosine theta and y equals r sine theta. There we go. All right, let me show you where I just wrote it on there. So see, here's the area of the triangle that I've added in there. So right here, I put x equals r cosine theta, y equals r sine theta. And that's going to be on your formula sheet, okay? So you want to add it to the one you have right now. But that's going to be on there so that you know how to get those coordinates, which is what you need for 18. You plug r in, you write cosine theta, then you plug r in, you write sine theta, and then you go to your unit circle. Cosine means pull the x, sine means pull the y. But then you do have to clean it up. So like right here, there's nothing to clean up. It just shoves together, which is why this is so ugly. I couldn't fit it in the box, so I wrote it over here. This multiplies to the 1, so you get 3 over 2. Number 19, find the trig function value. They give us sine, they tell us what quadrant, then they ask specifically for cotan. So this is, again, that basic geometry, but they're not asking for all 6 trig functions. They're just asking for a single one. What you have to be careful with here is drawing it in the correct quadrant, which it tells you, and then labeling the correct negative. So watch your negatives. You might want to make a note on that one. Watch your negatives. Let's see. So 19, I'm going to put geometry, but you're just finding one trig ratio. You're not finding all 6. And then 20 is checking to see, do you know where your positives and negatives are in all 4 quadrants? And do you recall that if sine is negative, then so would cosecant. If cosine's negative, then so would secant. If tangent's negative, then so would cotan. It's looking to see, can you make that connection? So on 20, I made a note for you. Nope. I made a note. I showed you my thought process. It says, what quadrant is cosecant negative? So my thought process was, okay, well, if cosecant's negative, then sine is 2. And then I said, well, what is sine? Sine is y over r. Where is y negative? Y is negative in quadrants 3 and 4. So then cosecant would also be negative in quadrants 3 and 4. So as far as topic goes, I guess I'm going to say quadrant sines, maybe is what it's asking. I'll put quadrant sines. Do that all ships transport cargo. Those are only the positive ones, or you could just break it down to understand, where's X positive, where's Y positive. I personally, the all ships transport cargo is nice and helpful, but when it comes to answering this question, I never used it. I just went with where is Y negative. Okay? So there's your final in a nutshell. Let's see, I'm going to highlight in orange the ones that are multiple choice. So you can get an idea. Okay, half of it's multiple choice. Half of it's multiple choice. Of the 10 that are not multiple choice, y'all look at this. Watch what I'm pointing to. 4, 9, 11, 4, 9, and 11 are all just the 6 trig ratios. So of those 10 where you have to actually do the work and type your answer in, 3 of them are just the trig ratios. So 7 of them are where it's either, we got 2 law of cosine problems, 2 law of sine problems, 2 polar problems, and 1 complex number and 1 unit circle. You feel better about it? Having looked through. So at this point, we're still in here till 9:45. The the solutions are posted. I'm also going to hang this solutions right here. So if you just don't want to, if you just want to come up here and look at it, you can. If you come to one that you don't understand, then you can ask me for help. Are there any other questions? Are there any questions? Can y'all be ready tomorrow to take it? I feel like if we push it to next Tuesday or Wednesday, the grades will be worse because things are going to come up, distractions. You're probably already done mentally. We are fresh off chapter 8, so those polar questions should be fresh in your mind.
I think we should take it
Tomorrow, yeah, that's what I'm thinking.
because it's pretty.
I don't think there's any, the only one that I would say is slightly tricky is that one that I've already called your attention to where you have to know to find the other angle first, then subtract it.